Hey, Steve Trimble. In this connected construction tip, we're going to show you how to do a pre-pour analysis of some scan data. So here, about 12 through 6, we have a post-pour analysis, some flat concrete that we do an FFFL on. But with an elevated deck, we're kind of stuck to the camber of the steel or the formwork below it. So here you can see this is pre-pour. We see some rebar, BT deck, a bunch of other stuff on the ground, kind of showing me where we could have some issues of this being too high. So if we have to pour 8 inches, they'll usually have a depth stick to check to make sure they get the 8 inches every time, because that's really important for engineering. The formwork is going to affect the FFFL because they're going to have to put down 8 inches regardless. So here you can see where we have some high spots here, and this can be seen in Field Link very quickly just with the elevation view. I can go through the floor analysis and create these points as well as just even come in here and click on one of the points. Let me turn off the model real quick to see where we're high and low. Did I turn off that model? I did not. Let me turn it off. But here you can see we're a little bit high. If we're going for 200 feet, 4 inches as deck, maybe add 3/8 of an inch for plywood, you can see we're getting a little bit high there. So what would be nice is we have some scans here with a reference elevation that should be about probably 206. Yeah, right there. Having more of those throughout the pour would help to make sure that these scans that are done actually where this deck is going through is in the right spot would be helpful, but we're able to tie back into that. So I can do these points. I can actually export the scans and view them in elevation in another program, Revit or Navisworks, or I can even do an inspection to the model where I can actually start to see high and low here as well too. Where blue is showing you it's higher because it's in the opposite direction of what it's looking for. So I can export that. I can create a PDF as well, kind of showing me that, or just do the points. Now, if I export this to RealWorks, I can ensure that my registration is good and do some other deliverables that we're going to show you here. So I'd export a TDX, bring that into RealWorks. Actually, in this production side, we're going to save this real quick. And then we'll come back to what you're actually seeing here. So this would be what it looks like with all those scans. We even have some wet scans that we should probably get rid of, but we have our pre-pour over here, our post-pour going through. When I move to production, you can see we have, turn this off, the same scans kind of showing me high and low here. And we have a couple different options within here. We're linked to some videos going through this. But what's nice in RealWorks is I can check the registration, make sure those are all tying in very nicely. Elevations matching, and even between scans, just ensure the pre-registration from FieldLink goes well. But once I clean up the data, which I can do with a bit more some segmentation of sampling, I can go into the inspection. I can run a floor inspection, which I believe is already done. Yep. And so what this will do, if I turn this off and come back one, is I can hit a reference elevation and then say anything that's like a 1/4 inch high or 1/4 inch low. I can create those same points or similar points, but a little bit better accuracy. So each one of these points is a grid line spacing of northings, eastings, elevations, and then deviation to the reference. And so that'll be created. The other thing that will also be in there, just to give you a better idea of where those points come from, is here's that same pre-pour floor. We can see some high spots, low spots, and in red would be above the 1/4 inch deviation that we had for analysis in between those two. So you can start to see where that's high. So I can create that. When the inspection grid is done, if I want to, I can send those points. I can also go into the Map Inspection Analyzer and start to create contours. We're actually going to leave this one. And what we're going to show you is, because we have the pre-pour inspection and then we have a couple scans that were done afterwards, we can do if we select both, a twin surface inspection. And so what that'll do is create, again, another inspection map that we can go into the map analyzer, and start to see the difference between the post pour, or whenever it's getting flat, and then the pre-pour. So as I move this up and down, this line is actually a sampler right here. So our finished floor is at 0, and inverse of the elevation, but the pre-pour is up here. So we can actually start to see where some of this is high. So this yellow would actually show me where it's essentially bumping up. This floor wasn't finished by the time we got there, but it's a good idea to kind of show me where we're going to have some poor FFFLs, because we're going to have to make sure that we pour above that when they start putting in the concrete. So that can be shared as the map analyzer, but what can also be shared is some grid lines like you see here as a DWG, where we can start to see high and low to those. Each one of these points would actually be reference to this, and we can see that along with the finished floor. So there's the, not the top of this one. There's the top of that. And so those lines can actually be exported as a DWG. So I can send points for an analysis. I can send the floor inspection analysis, and I can even send DWG grid lines to show me what the pre-pour is, and then as well as the flat pour. Moving in here, the other nice thing we can do here is with the post pour, essentially the flat concrete, I can also do FFFL. So this can be done in Field Link, but can really be tightened up here in RealWorks. What's nice with both programs is I can, and this was during a wet pour, so they were actually still filling it or floating this and bumping this. I actually kind of ignored this until they were done doing that. But I can start to draw lines for my FFFL. Because this is before the any bump cut or troweling, I'd kind of ignore the FF, but I want to make sure the FL is going well. And as you can see with some of these high spots, it's going to be difficult to hit good FFFLs, just because it's going to throw that off. So you can see we're already bringing this down lower. So I'd want to do the actual FFFL scans after the whole concrete, all the concrete has been poured and floated and troweled and kind of finished. But while it's pouring, I can give pretty good FL numbers to the guys. And then with the pre-pour, I'm really going to know where I'm going to have issues with my FL, and probably my FF as well too, just because it's going to be high, which we can see either just in elevation or with some of those other reports. So if I have this data, I can hopefully go out there and start to fix that formwork before they start pouring. So we can catch that and still pour the 8-inch of concrete that is needed, but then that'll help ensure that our FFFL going across this is good. A lot of times FL isn't even included on an elevated deck because it's hard to make the concrete contractor responsible for that, as the floor below may shift. But with this information, I can at least tell them if the camber or the plywood or the formwork is good before we get there, because it's hard to pour a flat floor when you have to hit 8 inches if the deck below it isn't flat. So use this information as you can, and hopefully start to fix these areas that you need to fix. And please reach out to your nearest building point partner if you have any questions. We showed you how to do some of this on the tablet in Field Link here. This is just on my desktop computer. And then how to get some better deliverables out of RealWorks.